In this video, we're just going to talk about some differentiation techniques with vector functions. So let's suppose that u of t and v of t are both differentiable vector functions, and f of t is a differentiable scalar function. Then we do have a sum rule, sum and difference. So the derivative of the sum of two vector functions will be the derivatives of each of those two vector functions added to each other. So I'm going to write that as u prime of t plus v prime of t. So this is the same as with scalar functions, where we have a sum and difference rule. And this could have just easily been a difference. The second rule is our constant multiple rule, where c is just a real number. And when we're taking the derivative of a constant times a vector function, we can take the constant out and just take the derivative of our vector function. So that's our constant multiple rule. I'll do some examples in upcoming videos. Now we have three different product rules, depending on the kind of product that we're doing between vector functions or what we're multiplying. So the first one is actually a scalar function f of t multiplied by a vector function. And here we just have the product rule, very similar to how we multiply scalar functions. So this is going to be the derivative of the first function, f prime of t, times the vector function u of t, plus the first function times the derivative of the second, so the derivative of our vector function. You can see that this will result in a vector. The second product rule that we have is when we are performing a dot product between two vectors. So notice here that we have a dot product between two vector functions, and so we have actually a product rule for dot products, and this will be as follows. We will have the derivative of the first function dot product with the second vector function plus the first vector function dot product with the derivative of the second vector function. Now notice, since we're adding two dot products, the result here will be a scalar. So just a note of advice, typically it's much easier to perform the dot product first and then differentiate, rather than applying the product rule for dot products. The third product rule that we have is that when we have a cross product between two vector functions. And once again, it's much easier to do the cross product first and then differentiate than it is to apply this product rule. But the product rule is very similar to the other two. We take the derivative of the first vector function and we cross it with the second vector function, and then to that we add the first vector function crossed with the derivative of the second. The result will be a vector. Now, just a note here, perform the dot product and the cross product first before differentiating. That's just more efficient. But you're always, of course, welcome to apply these rules. Either way, you will get the same result. It's just what's a little bit easier and more efficient to do. And then finally, we also have a chain rule. And here the composition is a vector function composed with a scalar function. And our chain rule tells us that this will be the derivative of the vector function evaluated at the scalar function at f of t. And then we multiply by the derivative of the inside, and this is a regular multiplication, f prime of t. And so there's our chain rule. And we will practice some of these rules in upcoming videos and as we get more familiar with the calculus of vector functions.